Hey everyone, doing LeetCode again in Kotlin. Today's question is container with most order. So you're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I of 0 and I with height of I. Find the two lines that together with the x-axis form a container such that the container contains the most water. So if you think of these lines and you could imagine creating a bucket and you could fill water into it. So you could have one right here and then this would fill with water. Any two lines could pretty much form a bucket with the lower nine being the height of the bucket. And to calculate the amount of water you can store is pretty much like an area formula. So right here we have a height of 5 and then a width of 3. So 3 times 5 would hold a water with like right here for 15. And you want to return the maximum amount of water a container can store, and notice you may not select the container. So for the first example, the answer is 49 with this given height array, and that's because it could hold the most water with the height of 7 and the width of 1, 2, 3, 4, 5, 6, 7. So 7 times 7 is 49. And to solve this problem, we are going to be using two pointers to kind of keep track of it, one from the left hand side and then one on the right hand side, and then move closer to each other and calculating the maximum area while we're doing this. And one key thing to point out is that while we are moving the pointer to either left or right, we should be moving the pointer with the lower height, because as we move the pointer, we notice that the width decreases, and it's better to keep the pointer with the higher height so that way a higher a higher area. So for example, if a first pointer is at um, 8 and then the second pointer is at 7, we want to move um, the second pointer over to the left. And the reason is because if the next one has a height of 8, for example, the current area was 7 times 7 is 49. And because we know we're moving one, we always have less. And the maximum, we know that can only be 8. So the next one we know is less. The width is decrement by 1, so we have 6, and the max is 6 times 8, which is 48, where if we move this one and then it has a height of 8 again, let's say we know that the maximum height could only be 7 for this case, and 7 times 6 is 42, and we know that 48 is greater than 42, so we want to keep the higher height for case like that. In case in the middle you might have something higher. So let's say this one was 99 and then we have another one over here that's 99. We would know that 99 times like 5 or something is definitely higher than 49. So that is the reason we are moving the pointer with a lower height. And so let's get started. We want to start off with a variable to keep track of the maximum area. So first gonna start with 0 and then we're gonna have two pointers. Uh, so we have a left pointer which starts at 0, and then we have a right pointer which is at the -1, which starts at the end, would be the right index. And then we want to do this while the left pointer is less than the right pointer, so that way we could increment decrement. And over here we want to check the height of these pointers. So if the height of the left pointer So if this is less than the height of the right pointer, you need to calculate the max area, and then we want to move left pointer uh, to the right one by one. So as I mentioned, because the height of we want to move the height of the pointer that is lower, so that way we could get a higher area going forward. And then same thing for the other case where the right pointer is greater than um or where the right pointer height is less than the left pointer height, we want to decrement the right pointer, and at the same time we should calculate the max area. So to do that, we could just call math that max area, comma, and the area which would be the smaller height times the width. So smaller height in this case was the left pointer, and then times the width, which would be the right pointer minus the left pointer. And then same thing for down here, we want to calculate the max area again. So we know that the height of the right pointer is actually the smaller one, so we will be using this as the height, and then the width should be the same, which is the right pointer minus the left pointer. And finally, we would want to return the max area to, uh, return the max area back to the function. I'll run this code. Uh, the size. Ooh, output is 0. Left pointer plus plus, right pointer maximum area. Oh, we forgot to set sorry. We set max area because we were just calculating but not setting it. And bam, should be the answer. Submit it. Cool. Alright, looks like it works. Thanks for watching, everyone.